Welcome back to The Explainer. So, I was just diving into the latest research on our global protein crisis. And you know what? It turns out the ultimate solution might just be microscopic algae. I mean, we are facing a massive challenge right now, feeding a rapidly growing population on a warming planet, all while our arable land is shrinking. But what if the answer isn't growing more crops or raising more cattle, but instead cultivating a microscopic, single-celled powerhouse?
Here's our roadmap for today. We're going to cover 1. The ultimate green protein, 2. A booming global market, 3. The extraction challenge, 4. Optimizing downstream processing, and 5. Feeding a changing world. We're going to zoom all the way in from the massive planetary benefits of algae down to the complex microscopic engineering we actually need to pull this off.
All right, part 1, the ultimate green protein and why algae is the future of food. Let's get right into it.
To really understand why this matters, you have to look at the math, because the math is just staggering. Microalgae can produce over 100 times more protein per hectare than traditional livestock. We're talking about 3.5 to 13 tons of protein per hectare every single year for algae, compared to a maximum of maybe 0.23 tons for traditional beef. That completely changes the equation on global food production. We can generate vastly more nutrition using a fraction of the space.
And it's not just about the crazy yield. Algae is practically an agricultural cheat code. It literally doesn't need fresh water. A lot of strains thrive in seawater, or even wastewater. You could build a closed photobioreactor smack in the middle of a desert because you don't need arable land. Plus, it grows year-round, doubling its mass in just 1 to 3 days. Nutritionally, it's absolutely packed with amino acids that easily rival things like eggs, soy, and wheat. Obviously, it's cruelty-free, and strains that are high in palmitic acid actually offer a direct, sustainable replacement for palm oil, which we all know is terribly destructive to the environment. It is essentially an environmental Swiss Army knife.
Moving on to part 2, a booming global market. Let's talk economic potential and regulatory wins.
Because at the end of the day, an environmental miracle only scales up if the economics actually make sense. And check out this number. By 2035, the market size is projected to hit nearly $450 million. That's a super solid 7.82% annual growth rate. So what's fueling this sudden boom? Basically, the regulatory red tape is finally getting cut. The US FDA recently endorsed a specific algae extract as a permitted food color, and the European Food Safety Authority went ahead and approved over 20 algae species for food and feed. This is huge because it shifts algae from just being some niche health supplement into mainstream food and beverage production. When we look at the global landscape right now, North America is leading the pack with about a 31% market share, mostly driven by huge demand for premium wellness supplements. Europe is right behind them at 26.2%, thanks to strict environmental mandates. But you really want to keep your eyes on the Asia-Pacific region. Sitting at 20%, they are advancing incredibly fast. They've got the highest growth rate globally, mostly because of massive sustainable cultivation expansions and government-backed nutrition programs popping up in India and China.
All right, part 3, the extraction challenge, breaking the fortress.
So, growing algae is relatively easy, but actually extracting a pure, usable protein from it, that is an incredibly tough engineering puzzle. To get our hands on the product, we have to cleanly navigate 4 phases of what the industry calls downstream processing, or DSP. You start with a super diluted algae broth. We're talking maybe 5 kilograms of algae per cubic meter of water. Through harvesting and dewatering using centrifuges or filters, we concentrate that broth down. Then comes the really critical step, disruption, where we physically break the cells open. Finally, we move to extraction, separating the proteins from the lipids and all the cellular debris. Essentially, we are trying to transform green water into a highly concentrated protein powerhouse.
But why is that disruption phase so notoriously difficult? Well, think of this tiny 10 micrometer tetracellular cell as literally a microscopic fortress. It has a tough, pliable, tri-layered cell wall. The challenge is we have to breach this wall and release the protein inside, but without generating so much heat or shear stress that we cook or destroy the protein in the process. It's a very delicate microscopic demolition job. It's kind of like trying to blow open a bank safe without burning up all the cash inside.
Which brings us to part 4, optimizing downstream processing. It all comes down to energy versus yield.
Breaking that fortress requires some serious mechanical engineering. It's actually wild how we do this. We rely on heavy-duty mechanical methods to breach the cells.
One standard way is a high-pressure homogenizer. It forces the algae fluid through a tiny valve at up to 415 bar of pressure. That sudden pressure drop creates gas bubbles that literally burst the cells from the inside out. But there's also a newer, really innovative technology called a calendar. This passes a concentrated algae paste between two solid steel cylinders that are separated by a microscopic gap of just 20 micrometers, literally crushing and tearing the cell walls wide open.
But the core tension here isn't just about breaking the cells. It's about doing it without burning massive amounts of energy. If you use more energy to get the protein than the protein is worth, the whole sustainability thing falls apart, right? So we use something called the Y value. This is absolutely the make or break metric for the whole industry. It measures the total energy input required divided by the total protein yield recovered. To make algae economically viable on a global scale, we have to find the exact combination of processing steps that yields the most protein for the absolute least amount of energy. Basically, we want that Y value number as low as humanly possible.
And when you run the extensive model-based analysis, there's a very clear winner in how we should approach this. It all essentially boils down to a massive battle against evaporation. The data shows that dry processing is the absolute winner. Why? Because heavily concentrating the algae early on during the harvesting and dewatering phases, like pushing it past 200 or even 400 kilograms per cubic meter, means there's way less water to deal with later. The final step of the whole process is thermal drying, which eats up massive amounts of energy. So getting rid of the water early on saves immense amounts of thermal energy at the very end, drastically lowering our U value.
And here is a really cool optimization trick hidden in the data. Extracting lipids using solvents like hexane does slightly lower your total protein recovery. But co-extracting both the proteins and the lipids yields an overall energy-to-product ratio that is significantly more sustainable. By pulling out the lipids for things like biofuel or omega-3 supplements and keeping the proteins for food, you're maximizing the output of the biomass. That combined product mass drives the Y value down to its absolute most efficient point. It's a total win-win.
All right, part 5, feeding a changing world. Let's get to our final takeaway.
Let's pull back from the microscopic engineering, all those Y values and the photobioreactors for a second, and just look at what this means for us on a macro level. The UN estimates that global food and agricultural demand is going to rise by up to 70% by 2050. We are going to have to feed nearly 10 billion people. And with traditional agriculture facing completely unprecedented climate pressure, severe droughts, and a serious lack of arable land, you really have to ask yourself, how soon will this incredibly efficient, fortress-breaking microalgae technology end up on your dinner plate? The science is ready, the market is absolutely booming, and honestly, the environmental math is undeniable. I guess the only question left is, are you ready to take a bite?